derivatives of trig functions. It revises it's a good topic because it revises the product rule, chain rule, and quotient rule, and integrals as well. And it also revises derivatives of other things like what's the derivative of e to the x?
E to the x.
E to the x, yes.
Integrate. Yeah,
exactly. What's the derivative of the natural log of x?
1 over.
Yeah, 1 over x. Kind of thing. That's it, yeah. And regular derivative stuff. So it's kind of a good topic because it ties in a lot of calculus stuff and tangents, normals, the second derivative test and all that rubbish. So it's a nice one to finish up on here. So from your formula booklet, earlier on in your notes booklet at the beginning of the circular functions, I posted in the formula booklet for this. What does it tell you that the derivative of sine x is? So if f(x) is sine of x, what is f dash x?
Cos x.
Yep, it's just cos x. Did you forget that? It's in the formula booklet. So that's nice to know. The derivative of sine x is cos x. You don't need to know why, you just need to know that that's the case and you use it.
Is it negative sine x?
Yeah, how do you know that?
I don't know.
So what's different about the derivative of cos x? It's negative sine x. On the next page, I show you a proof for why it's negative sine x. And same for tan x is a weird one. Anyone happen to know or have the formula booklet with them? See that front page? Remember the front page of your unit booklet? The unit booklet has the formula for the derivative.
1 over cosine squared x.
Yeah, 1 over cos squared x. And the next page shows you a proof for that as well. So the reasoning behind this first one, negative sine x, fx dash s is negative sine x, it's to do with horizontal shift. And the proof for this one has to do with trig identities and the quotient rule. So the proofs are, I'm bothering to do proofs for those ones because it's actually good practice of those things. Similarly, write out the integrals for those ones according to that thing. So the integral of sine x, what's missing when we write out the integral? There should be just the dx, yeah. The dx is missing. So integral of sine x dx equals, and the integral of cos x dx equals. Someone?
Sine x dx is negative cos x plus c.
Good. Where did you see that? So. Good, exactly. So don't bother trying to memorize these.
Pardon me?
So don't bother trying to memorize these because they're all in the formula booklet. Sometimes you might think you've memorized it correctly and you've got it wrong, so always just check in the formula booklet because you don't want to have that wrong. What was it again, Sarah? Negative cos x? Good, yeah, plus c.
Cos x dx1 is sine x plus c.
Good, yeah. Yeah, so it's positive or negative sine x?
Positive.
Positive, yes. Sine x plus c. Excellent. So the big plus c, in the IB they do uppercase C plus c. So if you're wondering what that is, it just means a constant that we don't know.
How would I know if my c is
I think it's just big, isn't it?
just big and
Yeah, relative to the size of the other letters. Yeah, so but in Australia, as I keep going on about, in Australia we use lowercase c. So I keep going to write lowercase c. I think they'll understand if you write lowercase c. They'll understand, I think.
I don't think in Japan a lot of c is a freaking c. They whoop people out.
No, I don't think so. I doubt it. They'll just think you're Australian. Plus, don't forget the product rule, quotient rule, and chain rule. So if our function, if it was a product of two functions, like if y equals uv, so I'm going to have to calibrate again. So if it was in the form of y equals u times v, like the product of two different functions, can anyone remember the product rule?
U dash v plus v dash u.
Yeah, u dash v plus v dash u. Good, so if it's y equals uv, then dy dx equals u dash v plus v dash u. That's not the form you get in the formula booklet. The version they put in the formula booklet is like d squared y x blah blah blah. So you need to be able to understand the one in the formula booklet, or just remember this one really well. I find it faster to me. Whereas if it was the product of two, the quotient rule. Quotient rule, if y equals u over v, what is our dy dx for that?
Isn't it u dash v subtract v dash u over v squared?
Yep, good memory.
Yeah, great, Krista.
Thanks, pals.
I missed it, Lise.
I did too.
dy dx equals good. U dash v, I'm going to put a boo-boo. What's a common boo-boo? Well, I do it.
It's supposed to be subtraction, so
Subtract boo, yeah. So the common boo-boo is it should be u dash v minus v dash u. Similar to that, but with a minus in the middle. Sometimes you can be so caught up in working out the numerator that you forget to put the over v squared at the bottom when you're doing the working out. That can happen. And the chaining rule. So chaining rules doesn't have like a version that you can kind of write out like this, but you have a mother. So you can have a mother function. And you can have a baby function. What letter do we tend to give the baby function? U. Yeah, good. So the baby function will tend to call U. So what you need to do is you write the mother function in terms of U. So if it was sine 7x. So imagine just, I'll do a quick example. You don't need to write it down if you don't want, because we've got more examples on the next page. So a sine 7x, what's the mother?
Sine.
Sine U, good. What's the baby? Yeah, U equals 7x. So you've got to multiply the derivative of the mother by the derivative of the baby.
wait, so what's the thing when we do the derivative of the mother by the the
Integral.
reciprocal of the derivative of the mother?
Yeah, that's a hard one. That's integral calculus.
How do we do it?
So you do the reciprocal of the derivative of the baby multiplied. This is for integral calculus, not this. So for that one, it was the reciprocal of the derivative of the baby is multiplied by the integral of the mother.
Yeah.
Whereas here it's much simpler. Derivative of the baby times the derivative of the mum, and then sub u in at the end if you want. And then, so what's the derivative of sine u, according to those funny rules at the top?
Cos u.
Cos u, yeah. So it would be cos u times, what's the derivative of the baby?
What is the baby? 7x, so 6x?
Close?
No, the derivative?
Yeah, derivative of the baby. So it's been a while. 7, good, yeah, just 7. So cos u times 7. So the answer to that would be 7 cos, and then you sub into u. So I don't know why I did a whole example there, because there's plenty of examples on the next page. So what you do is another function, baby function. So you multiply derivative of the baby by the derivative of the mother and then sub u in at the end. If you can simplify anything you do too. Sub u back in it at the end, as in whatever u is, I'll get rid of this. So chain rule doesn't have a special easy thing to remember like those ones, but it's kind of got a pattern to it. So the functions are printed. So another function, baby function. On the next pages, we're just going to practice them. So it's actually good because it revises all this chain rule, product rule stuff. And then next lesson, Tuesday, I think, we'll be doing a bit of this stuff with integral calculus as well. What are you saying there, Bella? Oh, sorry, I should just move on. Prove. Okay, prove that the derivative of tan x is 1 over cos squared x. Normally I don't bother too much with proofs, but this one is good because it involves trig identities and the thingamajig, the quotient rule. So tan x equals what according to the trigonometric identity? Oh, that's the derivative of tan x. Yeah, so we're going to prove why.
Is it just cos 2x?
Yeah, what was that, Kieja? Yeah, do you remember the trig identity?
Yeah.
Yeah. Yeah. So that's the trig identity. The trig identity it's called. And so now we're going to differentiate this thing, this version of tan, using the quotient rule. So we differentiate sine x over cos x using the quotient rule dy dx, as Chris has said, is u dash v minus v dash u over v squared. Oh. Now underneath that is where we're going to write out our answers. What I like to do is I like to write out u equals, v equals, and then underneath it u dash equals, v dash equals, and then sub it all into that thingamajiggy. So I said to do that on the side. Yeah, SL is basically should be called calculus with a little bit of the other stuff.
Yeah.
Pretty much, yeah. So what's our u function?
Oh, it's cos
Sine x, yes. Yeah, u's always the top, the numerator, yeah. So think alphabetical order, u over v. So the u has to be the sine x, and the v has to be the numerator. The denominator, sorry. So the u is the numerator, v has to be the denominator. Kind of goes in alphabetical order. So I like to write out what u is, what v is, and then what's u dash?
Cause u.
Goodness, really close.
Not
It's just negative. It's even is you. It's cause just cause x. Yeah. There's no babies or mothers in the pro.
Oh, I said u. That's the answer.
Yeah, that's all. Yeah. So your math is right. U dash is cos x. What's v dash?
Negative sine
It's
x.
negative sine x. It can be really easy to forget the fact that it's negative sine x. So definitely, when you're doing these ones, just have the formula booklet out, and then we sub these things into the product rule, and you'll find that it's going to simplify to 1 over cos squared x.
Yeah, exactly.
So in the product rule, dy dx.
Oh, what were you
So
saying?
there's going to be quotient rule. Sorry, yeah, you're right. So this is interesting. U dash v. So that one times that one is basically going to be. You can say cos squared x, or if you want to do cos x times cos x, because you're just showing the first step if you want. Cos x times cos x, which is going to be cos squared x. You're welcome to go straight to writing that if you want. And notice it's minus. So minus v dash u. V dash u. So minus sine x in bracket by sine x. It's horrible.
It is over
Over v squared.
cos x squared.
Yeah, cos x squared.
That's cos squared x.
Yeah, you can go straight to writing cos
Is
squared.
that second bracket? I mean,
Yeah,
is that negative?
Yeah, and minus, so because it's minus in the formula. And then notice it's a negative sine x plus sine x. So this first bracket there is negative sine x. The second one sine x though. And then so that step, when you work that one out, oh yeah, cos squared x. So see, you've got to be very systematic. You've got to be very systematic about shoving stuff into the formula. So that's why it's good to sort of write them out and be really careful. U dash v minus v dash u. Be really systematic, kind of like about how you sub stuff in. And I bothered to do this because otherwise I might have made a little error in the minus minus. I might have missed the fact that it's going to end up being a minus minus. So it's going to become plus sine squared x overall. And if I didn't do that first version, I might have missed that. Over cos squared x. And a little clue is it's going to end up becoming 1 over cos squared x. So it's going to be, because they said already that the derivative of tan x is 1 over cos squared x. Why is that? Why do you think the whole numerator is going to become 1? Yes? Yes, the Pythagorean identity. What does that say?
One.
Yeah, exactly. Pythagorean identity says that cos squared x plus sine squared x equals 1.
Yeah. See,
Yeah.
mamacita.
Yeah, that's a 1. That's a 1. It's not a whatever that is, lambda. So that's why. So that was a good proof to do because it involved like calculus, which is what we have to learn to do here. So that's a 1 here. That's it. I'll type it in that way. So cos squared, yeah, Pythagorean identity. So see how the trig identities, that's why we have to have done the previous chapter before we do this one, because the trig identities really factor into calculus with trig. And that's why when you first did calculus, you didn't do any stuff with trig. It's because you have to have learned the unit circle, and you have to have learned the trig identities to be able to do calculus with trig. Do you want to memorize them?
Do I have to memorize it?
Oh, they're in the formula booklet.
Oh, all of them?
Yeah, like the double angle formulas are, the trig identity is, and the Pythagorean identity is.
You can tell me the other.
Nothing about the unit circle
When
really.
do you finish the hills of Olympians?
Probably like right through to the end, unfortunately. Because we still got to do vectors. No.
That's easy.
Yeah, vectors is easy. Normal distribution, a bit of probability too.
He has it.
Like probability review basically.
I love probability.
So they're nice topics. This is the last hard topic, I'd say. This is the last hard topic.
I love
Yeah.
probability. I thought it was existing.
Normal distribution, binomial distribution, vectors. What?
Okay, so let's not learn it for always sake.
You're gonna love it, Owen. By the time exams come around, you're gonna be like, oh yes,
You're gonna love
it's a good chain rule problem.
I'm not good at it though.
Not yet.
That's a pharmacy.
Is anyone writing? I'm doing this. What's happened to the upstairs one?
No one knows these toilets don't flush properly. People like to flush tampons down. You should complain. They just don't flush.
It's the water pressure that's the problem.
Do they have plungers in there at least, so if stuff gets
No.
stuck, you can plunge
And
it?
even
They should do that, because then you can easily just plunge and then it goes away. But like, if you don't have that, there's nothing you can do. Another one we're going to prove is, we're going to prove why is the derivative of cos x, Gracie? Why is the derivative of cos x sin x? And this, remember the proof for this one is actually to do with horizontal translations. So, because when you think of it, let's do a little sin x graph and a little cos x graph. So here's sin x starts at the middle, goes up and then down. A full period, that one's sin x, this one's cos x. So cos x starts at the top. What's the period of a sin x, regular sin x? Yeah, or in terms of pi?
Pi. 2 pi.
2 pi, yeah. Okay, yeah. Because it's 2 pi over b, and if it's sin 1x, please pay attention. Because it's 2 pi over b, and if it's sin x, then it's b is 1. So 2 pi over 1 is just 2 pi. What's the period of a cos graph? 2 pi. It's the tan graphs. Tan graphs are the different ones. They have a...
Es lo mismo.
So, yeah, just pointing out that they're both pi. So this one's pi. And notice that cos x is the same as sin x translated, or sin x translated. How many units left? So say if I wanted to make
Half pi?
yeah, if I wanted to turn a sine graph, yeah, good, into the cos graph, how many units left should I shift the sine graph to make it turn into the cos graph? Really close?
Pi over 2.
Over 2. So do you want to start here? And that's at pi over 2, yeah. Initially you think pi, but pi over 2. So So notice that cos x is the same as sin x, translated, pi over 2 units left. So I'm writing this so thin because my board, after I calibrated, it just got even worse. So I'm just going to, you don't need to write it as big as I am. I'm just having to write it big. Okay, this is hard stuff. Let's concentrate. So notice that cos x is the same as sin x. So therefore you can say that cos x is equals sin x something.
Plus pi over 2.
Yeah, good. Plus pi over 2. Because it's, why is it plus pi over 2?
It's opposite.
Yeah, because it shifted left. Bella, why is it plus pi over 2?
It's a shifted left.
You're
What
good.
does that mean? Why did it shift left?
Because it's like, it moves, because that's like that, so when you move it at the top, it shifts left so that it goes up the axis.
It's the opposite.
Okay, so you are multitasking. Okay,
I'm
so
not even multitasking. Listening.
listening with your head facing Grace. Poor Bella. You,
Her ears to you.
yeah. Good try. So back to here. So prove that this. So what we're doing is we're trying to prove that the derivative of cos x is minus sin x. So therefore, if cos x equals it's the same as that, we can differentiate this. So let's try to. What method would you use to differentiate this?
The sin x thing? The sin x thing?
Chain rule. Yeah. Why would you use the chain rule?
Because it's got a baby function and mommy function.
Yeah, it's got a baby.
Plus.
It's the mother. It's pregnant.
Sarah.
So differentiate this. Using chain rule. So what's our mother?
Sin x. Or sin u, I don't know.
Yeah, sin u. Yeah, mother is sin u. What's the baby? Yeah, x plus 5 over 2. So right at the mother, right at the baby. What's the derivative of the mother?
Same. Oh, cos u.
Cos u, yeah. So cos u. End up in cos u times. What's the derivative of the baby?
What is the baby?
X plus pi over 2.
Pi over 2.
Close. Pi over 2 is just a number.
So is it just 1?
Yeah, why is it just 1?
Because 1 times 1 is 1.
Yeah, because it's like 1x. Think of it as being like 1x plus 7. Then that would just become 1. So a bit tricky. This is good practice of calculus because it's learning. So something like, because it's 1x, so it becomes 1. And pi over 2 is just a number. There's no x in it. So it's just a constant that flies away. Remember, a constant term just doesn't appear in the derivative. What's that, Gracie? We differentiate. So you define the mother and the baby, and you differentiate both and just count them together. So the derivative, so it will be, that's not the answer by the way. So cos u times 1 equals?
1 cos u.
Yeah, 1 cos u. Which written, and then stuff, so we don't need the one in the final answer.
Cos x.
Good. X plus pi over 2, good, so you sub in.
No te lo verme, sorry.
So this is so what we've done is we've proved that sin x plus pi over 2 using the chain rule differentiates to give us cos x plus pi over 2. But have we proven yet why that technically is the same as minus sin x?
Oh, no tengo demasiado espacio azul.
That's right. So let's do a quick sketch of. So here's regular cos.
Right.
Here's regular cos x. If you shifted cos x according to that thing, so remember the period's 2 pi. 2 pi. That one's pi. So if you, according to this, has cos been shifted left or right? Left. How many units?
Pi over 2.
So therefore, where is that on here?
Where the bottom would be at the origin.
Yeah, period is 2 pi.
Yeah.
It's at that first
Pi.
spot where it's right there.
Yeah. So So now it's become that, hasn't it? So now see how it's become. And what do you notice? So that is cos x plus pi over 2. What's that the same as?
Sine.
Close?
The negative
But the opposite.
sign.
Yeah, it's the upside down sign, isn't it? So,
What's the face?
cos x, which is upside down sine x. X or negative sine x. Exclamation mark out there. So we've just kind of used a bit of horizontal translations and a little bit of chain rule to prove how y cos x is minus sine x. It's because cos x is the same as sine pi plus pi over 2. Cos x plus pi sine. What is it you write?
What does
I like my
at
church.
the bottom? That little, what's those things?
Oh, they're meant to be exclamation marks, but they look shocking. So I'm going to get rid of them. I was just trying to make a point that that's a big point down there that I've made. So this is kind of like we've proved that the derivative of cos x. If you find this hard, you need to concentrate. So we've proved that the derivative of cos x is that thing, and then which when you graph it is the same thing as negative sine x. All because of like the fact that sine x's and cos x's are the same graph, just shifted sideways. Is that good? Is that fun? Does that thrill you?
Yeah.
Some people are writing, so I'm just going to eat some turkey soup. Lauren, how was the plate?
Lauren was like,
I'm going tonight.
You were so.
Lauren was like over the side. She was
I don't know what.
Sorry, how are you to eat your lunch at lunchtime?
I do, but I have to help science with a Google Classroom setup thing. And this takes a long time to do. There was a lot in there. And it's really good. I don't want to miss out on it. Okay, we're on the next page. Now we're just on to some practice ones. 8! 2 more pages. 2 more pages.
No smart. You know, shouting. Just you're like frustrated.
and then she
So Mia 9, oh, page isn't here. So Mia 9 said that there's a picture of my dog on page's Instagram.
What page is Instagram?
Yeah, and they,
was just her story.
and they didn't know what it was until they realised when I said, oh, my dog was in the IB centre on Saturday. They said, oh, that was your dog.
$2 you brought.
I growled at him. Oh, you wouldn't listen, so there's no point. He's too young. What do you do? Like, I know you've tried to tell me, like, if they do something naughty, you give them a little smack, but that does something.
Some people tap them on the head.
Yeah.
That's what they're fighting.
Exactly.
In Australia, my brother would spray them with, like, they get a water spray.
That's what I do.
I don't believe they fucking go.
Yeah, we haven't done that. We haven't done that yet. I thought that low
she's so cute. I'll like blow on her nose and her face, and she goes.
And we just have to keep saying the same word to you, though, in order for them to learn. And I say stop, and I point my finger, and he will sit down.
So not no or anything like that. Oh, yeah, maybe no. But because I sort of figured, like, if we sprayed him, he's too young. I don't. If he'll just be sad and he wouldn't understand why.
So you're supposed to teach them when they are young if you want.
Oh, really? Is this like 4 months? Is that too young though? Like, some say you should. Some say they can't. So some say they can't be trained till like 6 months.
Oh, I haven't heard
They
it.
don't take them till like training.
You want to do that? So you can work stripes like until he's set, and he hasn't said don't. keep saying
We're gonna take a tree and do this over the head.
You will? Oh, then you'll only do what you say more. So just say it, and if he doesn't do it, just wait till another time. And when he does do it, I find it way forward. It's like he really doesn't put much attention. So if he's outside, he won't come in. That's going outside and potty. He'll like sit there and just he doesn't want to come. But then if I get out the squeaky rabbit,
I want to see my dog eat peanut butter.
I love peanut butter.
They do.
Dogs love
that's true.
They don't love it, but they want it. My dog loves peanut butter too.
Alright, so let's do some math. We've only got 20 minutes, we'll get through it. Find the derivatives of the following. This is a nice one. So for cos x, what's the derivative of cos x?
Negative sine x.
Bella, what's the answer?
Okay. Let's go.
What is it? 4 sine x, yeah.
negative 6x.
Yeah, it's a tricky, it's a awkward one, the next one.
Is it negative 4 sine x?
Scoring negative sine x. Negative or sine x. Minus 6 cos
negative
x. Negative
sine x.
Oh, it is, isn't it? Yeah, sorry. Thank you. Yeah, so it's 4. It's kind of like 4 times negative sine x. You might want to do that first, to set it up like this first. Minus 6, and then Sarah's right, this one's the positive one. Because the derivative of cos x is negative sine x, derivative of sine x is positive cos x. So definitely have the formula booklets open when doing stuff like this, so you don't do the visual. Then you can times them. So minus 4, negative 4 sine x, minus 6 cos x. And then you've got your answer. So this first step kind of just avoids things going wrong with negatives and stuff like that. It's a bit of a pain. Tan squared x.
Ooh.
Let's rewrite that.
10x squared.
Yeah, it's just like saying tan x squared. So what method would we use to differentiate something like that?
We would use the chain.
Chain, yeah, because it's pregnant.
Okay, Miss Melody.
What's a mother?
U squared.
Good, yes, mother is u squared. And the baby? 10 x, yeah, but so mother is u squared, baby is tan x. And then I just tend to underneath them write the derivatives of both. Good, 2u. What's the derivative of tan x?
1 over cos x squared.
Good, yeah, 1 over cos squared x.
Cos x squared.
So those two go together. And then you kind of pop it all together and simplify it.
So,
The topic is not Mr. Monday.
would it be 2?
Guys, there's too much extra chat. This is hard stuff you should be following. Okay, so 2u. So what Sarah's done is she's multiplied 2u by 1 over cos squared x to start with. And then in your final version, what would you sub in?
Tan cos.
Back into
What is the baby again?
Tan cos.
Good. So 2. It's confusing, isn't it? You have to go super carefully, don't you? Over cos squared x. So 2u is like 2 tan x over cos squared x. Sometimes there might be ways that you can. You might find that you can. So sometimes they might say prove that this is another thing, because remember you could always replace tan x with sin x over cos x. So
10x is what?
so
Sine x over cos x?
yeah. So just be aware, trig identities. Trig identities can factor into this a lot, so this is fine as an answer. They might say prove that the answer is actually some other version of it, because you could replace the tan x with sin x over cos x. So then you would get 2 sin x over cos cubed x, wouldn't you?
Mm-hmm.
Yeah, if you time, basically it's like 2 over cos squared x times sin x over cos x. Then you get 2 sin x over cos cubed x. So just be aware they might say prove that the answer is that version instead. And you just use trig identities and you experiment around a bit. Kelvina, you know this. What's the derivative of e to the x?
70x.
Oh yeah, 70x is 70x. You're good. So derivative of e to the x is just e to the x.
Well, she said like 70, and I would say no.
But what method do we need to differentiate this?
Baby.
Yeah, mothers and babies. So we might want to, you might want to just deal with this bit first, and then just don't forget to do the whole thing at the end. because you've got to define the mother, the baby for this bit. So let's just focus on this little bit to start with. But then just don't forget that you've then got to look at the overall function in your final answer. What's the mother?
Because you.
What's the baby? And then what's the derivative of the mother? Okay, good. Next, yeah, negative sign u. And the derivative of the baby? Owen, pick up that pencil and tell me what's the derivative of the baby? Derivative of the baby? And then you times it all together.
-5
Good.
sine u.
Nice work. 5 sine u, which is -5. What's wrong?
5 sine u, wouldn't it be -5 sine u? Oh, sorry.
Oh, maybe I wrote it and didn't say it. Sorry. Yeah. So and then do you know what? So I could walk away from this and go, hey, I finished. I got a full marks for that. Yeah, good, exactly, yeah. So notice all I did was I did that whole business took a lot of work, and then I don't forget that the final answers got 70x in it, differentiated too. Yeah, so that's like a little subsection in itself maybe. And then this whole thing we'll do down here maybe. So try to find ways to be all systematic about that kind of thing, like section it into columns or something. So maybe you want to have a left column and a right column, and in the right column's where you did the cos 5x visit. Yeah, like have it all segmented so you don't forget. Whereas if you do it linear like this, you could walk away and forget. Whereas here, if you had it over there, you'd realize, hang on, what did I have that column for? Might make you remember. If you space out like I can do, then it is straight like that. What's the derivative, Kalina, of 70x? Yeah, so 70x minus 5 sine 5x. Sorry, that was just I haven't done the answers to the next one. Oh dear. Yeah, it's only 2 o'clock. Let me check how to do it. Oh yeah, you do to the -1. Okay, cool. So for the next one. Good, yeah. So Kiesha, what's the derivative of natural log of x? No, I'm just staring at you to make you feel bad.
You sound like Damon.
And the reason why is that Bella was just like this. Yeah, you did.
Just looks around.
Sounds a little aggressive.
It was like taking classes.
She was doing something wrong.
So maybe let's try doing that whole thing like where you split into columns, like so you don't forget stuff. Or let's maybe do it like that. So you can kind of break it up like that. Oh yeah. Root of ln 1 over x. So this thing came from the formula booklet. So that thing came from the formula booklet. Dolly, did you go to the hairdresser yesterday? Yesterday or the day before? No, you went to the hairdresser. Yeah. That wasn't yesterday, was it? That was the other day.
That was the day before.
She's like, why is he so confused right though?
How do I switch? By the way, ow.
You get
Oh, nothing. What, Bella, were you going to say, by the way? You just said, by the way, and then Owen pulled your hair out.
I think she means, why would you ask?
Yeah, why are you asking? You like, by the way, this is why
Yeah, you said by the way.
You said
by the way. So I was like, why did you say by the way? Why did you get your hair? How was your haircut or something? Like, how did you switch to my hair?
Like, what
I
was
just
your
remembered that you got your hair cut. How do you know that?
Not just like the
Yeah,
problem.
conversation with Elliot.
It's child acts just like you.
Alright. So what? So we found the derivative. How do you know the derivative of ln x is 1 over x?
Formula booklet.
Yeah,
Because we know that prior.
So I would say maybe write that formula booklet. This is the interesting one. 1 over sine x. How come you wouldn't bother to use the quotient rule? Like why? Quotient rule is when you got a function on a function.
Because you have a love.
One's not really a function.
Can't have a mother and a
Really,
father.
it's technically a constant function, but it's got no x's in it. If it's got no x's in it, then
So.
how can you rewrite sine x? 1 over
Sine 1 is 1x.
yeah, sine minus 1x, yep. Or sine x minus 1, yeah. So sine minus 1x or sine x minus 1. It's the same. So really, I've just rewritten the function. So I'm just actually.
Por favor.
So
I have
I'm going to just say rewrite the function. Rewrite it as sine x to the minus 1. So rewrite as sine x to the minus 1 is what that's meant to say. Rewrite as sine x to the minus 1. Yeah, good. And then you would use the chain rule on that. So what's the mother?
U to the negative 1.
U to the negative 1, good. And what's the baby? Good, sine x.
Dollars are real now.
Now what's the derivative of the mother?
Negative 2.
negative u to the negative 2.
Good, negative u to the negative 2. And what's another nice way of writing that?
What are you doing?
1 over u squared.
So it's negative overall, 1 over u squared. That might be a nicer way to write it. So so you might want to, because that's awkward to multiply and sub in. So you might want to rewrite it as negative 1 over u squared. Both are okay in the meantime. What's the derivative of the baby? Cos x. So to be honest, you could multiply either one by either of those by cos x. Eventually they might want that version because it just looks a bit more
Mathy.
Yeah, it looks a bit nicer. So they might accept that. They might, yeah. Oh, look, if they don't say write it in this form, you're fine. You can leave it with minus 2 in there. But they sometimes like you to say write it as 1 over there. So if you times those two together, what do you get? You get minus
Cos x over u squared.
good over u squared, which when you sub in the u is
Minus cos x over sine x squared.
what's u again? Oh, it's sine x. Good, yeah. Well done. Sorry, it's just I'm trying to scroll it up so I don't write in the dodgy bit of the board that's all messed up. So the u is sine x. So that's the same as minus cos x over, as Kia just said, sine the baby squared.
Hello. Okay, but we're trying to get it done.
Or
I thought it was 1 over u squared.
Yeah, you heard that aggression, right?
I could imitate a lot.
Yeah.
so notice that sine x squared is the same as sine squared x.
See, you'll see.
So see we subbed in that. And is that the final answer, this thing down here? Or- yeah, what should I also have? Yeah, good, the plus the derivative of that thing, yeah, good. So just give a bit of space to do that at the end. So minus cos x
It's
over sine squared x plus 1 over x, wasn't it? I'll try to subtract that. So overall, just trying to write it a bit nicer. So overall, it's like having a minus out the front of that. So I might prefer to write 1 over x. You know, some mathy people like have the positive
Wait,
thing.
where did he get this 1 over x from?
Exactly. From pay attention. Where did you get this one over x from?
Yes, x.
You conservative.
X plus x.
Negative cos x over.
Sine square x plus x.
That's a good point. To be able to add two fractions together, you need a common denominator. So that which would be painful. But yeah, like maybe, you never know, they might make you do that one day. So if you had a common denominator, it would have to be x sine squared x. And then you would have to do that, and you might find things simplified if it would be that simple thing. But that would probably be a show that question. Show that this becomes that nice simplified version. So yeah, cool. So this could be one where, like they say, prove that that equals actually something else. In which case you might be asked to sub in trig identities. You might be asked to replace sine squared x with 1 minus cos squared x. And then, but that's, if they don't, then just leave it like that. That was pretty complicated. Hey, very complicated. Oh, we still got a page.
We've done a lot of math.
Yeah, it's good though because it's practicing the like IB1 calculus and all that kind of stuff. No,
A lot.
you can do a lot of it after this, to be honest. Just see where integral calculus, it's the same thing, but you're using the integrals. So if you see any integration questions, it's just the same stuff, but with the integrals instead. No, because I want to do one more. Oh, hang on, I don't even have one more.
Oh, whoops.
I haven't pasted in the thing, sorry. So you have a little moment while I do that.
Yay.
Page, what page is this? Page
Yeah.
33, is it? No? Yeah, 33.
My hundred cards serious.
Because maybe you should go through the topic assignment and say which lesson is for the questions.
Maybe.
I think it should be there.
Maybe. Okay. Try. Okay, there we go. Control S. Fabo. Might be handy to have a calculator if any of ours would work today. It'd be so funny if the online version was also flickering. Might be useful to have a calculator. I can't remember. These are pretty intense. So, first of all, we'll just do probably the top one for now. Find the equations of the tangent line and the normal to the curve of fx at the point 2 tan x, at the point where x equals pi over 4. Finding a tangent line. So what we've got to do first of all is, they've given us an x coordinate of the tangent. If it was on calculator, I could show you what to do. So if it was on calculator, what mode should I be in? Radians, yeah. So I'll do it on calculator first, so we can just get an answer. So I'll go to my mode, make my mode radians. Where's mode? There it is, mode. Oh, yep, radians, because we're dealing with pi instead of degrees. So radians. And I would probably just do a graph of 2 tan x. So I would graph 2 tan x. 2, where's tan? How can I not see tan? What's wrong with me? There it is, tan x. 2 tan x. Have a look at your window, see if your window's a bit rough. A regular tan graph, what's its period?
180.
Or in radians?
Pi.
Yeah, so maybe like try to put in some numbers that are kind of like more like that. Like -1 up to, maybe we'll go up to 2 pi. Something like that, and then see how it graphs. Whereas otherwise I'll have like, if I don't do that, so if I had have left it,
So what's your y? You just left it?
yeah, I left it at 3. So if I didn't do that, what would be the problem? Like, why would it take forever to graph if I had left it at -10 to 360?
Because they have to do all.
Yeah, there'd be like stacks of them. Because this is really, 2 pi is like 2 times 3.14. So that's as far as this one's gone. So that, it didn't say what kind of like thing to use, so I just thought I'd do that. So where's pi over 4? So can you remember where's the first asymptote? 90 degrees. Yeah, pi over 2, good. And this one I've got to 2 pi, so pi over 2. Hang on, wait.
Is it 3 pi over 2 is the next one?
No, pi over 2 is not where the first asymptote is. Wait. The period? The period.
Thinking about it. She went like that to think.
Oh, it? No, hang on, I'm also thinking as well. Are you saying it? So here's pi,
He's pi?
here's pi. Good, pi over 2. Is that what you said, wasn't it?
Yeah.
Yeah, you're right. Sorry, I don't know why. I was thinking for some reason pi over 2 is here, but it's not, it's there. And that's where the asymptote is. Why is pi over 2 the first asymptote? You're totally right.
90 degrees.
90 degrees, and at 90 degrees, cos is? 0, yep. And so sin x over cos x would be 0.
I know why cos
Yeah, why? Just because half?
the whole.
Yeah, maybe, yeah. Don't know what my brain
I'm sorry.
Yeah, I was kind of then double what it should have been or something. Okay, so notice where x equals pi over 4. So here's pi over 2. Where would pi over 4 be?
I'd be 49.
45.
About here, yeah. So around about here. So out of interest, the equation of the tangent, remember a tangent's just a straight line that represents the gradient at that point exactly. Is the gradient going to be positive or negative?
There.
Yeah. Positive, yeah. So when we find our equation of our tangent, we expect that the gradient's going to be positive. The y-intercept could be somewhere close to 0, couldn't it? Because if you did a tangent there, you'll probably find it's kind of a line. Maybe it's down in the negatives. How do I draw a tangent on my calculator again?
Oh, 5, isn't it? Is it number 5?
Second, yeah.
How?
Close. It's somewhere special that
Trace, window.
I'm gonna draw a tangent. Where do I go? I have to go. Give me an answer. Give me an answer.
Second.
Right. That's what Keo just said. Good. Hang on, wait.
Program is 5.
Yes, good. Second program. Why is program a good one? Because what's
Program tangent.
no? Because what's above program? Get your calculators out so you can look.
Draw.
Draw. So you're drawing a tangent. Good. So second draw. Second draw. Good. And what thing should I press?
I remember it was 5.
5. Yeah, for tangent number 5. Now, what's confusing is you're there going, what do I do next? It doesn't prompt you. Can anyone remember what you do next? We need to find the tangent at x equals pi over 4. So we've got to tell it, find it at pi over 4.
I would just type in pi over 4.
Yeah. And what happens when you do that?
That's what happens. It goes to the x equals pi over 4.
Circle draw, dude.
Good. Yeah, so it doesn't prompt you. You've got to realize, oh, I've got to type in the x coordinate. All right, fair enough. So, yeah, okay. So we graphed that. We made radians first. We graphed it, and then we adjusted the window so we could see it nicely. And then you see that. And then you went second draw a tangent. And then you typed in pi over 4. I'll just quickly put that in. So yeah, write down what you did to get that. What's the equation of our tangent? It's hard to see from the distance. So I'll make it bigger. Because? So it's always a little bit off, so assume that it's meant to be 4. 4x minus that to 3 sec theta.
It's 220. That's not true.
Oh yeah, it is a bit slow, isn't it? Yeah. Okay, we can finish there.
Thank you for giving us one talk. Hey, are you ready to begin this study?
Sending me